David Thompson. I work in the Environmental Information Unit here in DUW, and the work I do generally goes across our corporate databases. So by database we have like the textual database like BDBSA as well as GIS databases. So I'm going to be talking today about a case study where we've been integrating the BDBSA with some GIS tools. The business area that I'm kind of representing here, and I don't profess to know everything all about it, Dew is implementing the Murray-Darling Basin Plan. And I've only ever had a very small contact with this, and mainly around the monitoring obligations that we have. And we do that monitoring to test the effectiveness of the basin plan over time. We have evaluation and reporting on some of the outcomes, and specifically on the environmental water plan, which is considered as Matter 8. And this is something done at the asset scale by the basin states. And so for this particular case study, it's kind of focused in on the floodplain, and it's something that we have to do every 5 years. The environmental water plan allocates environmental water to meet ecological needs of plants and animal communities along the river. And one of the objectives under this plan is to maintain viable floodplain tree communities. Over time, a methodology has been developed that's now been endorsed by the Murray-Darling Basin Authority and the basin states for the ground-based assessment of tree condition, and this looks at River Red Gum, Black Box and River Cobar in South Australia. The particular method, it looks at the condition of 30 trees along a transect, and they're assessed for a range of condition parameters, and two in particular that are important for what I'm talking about are the crown extent percent and a score from 0 to 7, and the crown density percent and score from 0 to 7. And from these two particular attributes, a tree condition index is generated by summing up those two scores. So you end up with a score from 0 to 14, where 0 is basically a dead non-viable tree, and 14 is a tree that's in excellent condition. And when using this information, there are floodplain-based targets that get devised that try to look at what kind of target or what kind of index you'd be wanting at that site. And so here's an example which I've taken, and it's from Pike floodplain near Renmark, where along the standardised transects we're looking to have 100% of viable trees along the transect with a tree condition index score greater or equal to 10 by 2030. And so these targets kind of change depending on the floodplain in question. With this method, the tree condition index can be tracked over time, and generally it's compiled and analysed in Excel, and then it gets summarised in technical reports like these ones here. And just as an example, it quite often gets tracked as charts. And so here we've got 2 different years for the same particular site. But getting this data into BDBSA was something that I was looking to help with, and we used the 3 worksheet format, which I know I'm not allowed to call the complex site template, because it's not complex to use, it's quite easy. And the assessment, I guess the key to this, the assessment site and tree ID went on the site tab, and there was some nuances around actually naming individual trees within an assessment site. So we've got, like here, an example, Pike site 13, tree 1 to tree 30. So there'd be 30 sites defined for that transect. With the visit tab, you can record the baseline survey, so the initial visit, as well as any revisits to the site. And the tree condition parameters, they're on the species tab, and they're right at the far end. So if you've never scrolled right to the far end of that particular worksheet, that's where they're found. And then linking with other GIS tools, came up with a Python script which allowed interaction with both the BDBSA tables as well as our spatial databases to extract the data that was required to do some value adding and create some new layers and tables. The BDBSA was used as the source for the tree condition information, and Aegis, or our spatial database, I used the Flora super table to extract the spatial locations of the trees. Once the new layer and table was generated, there was a service request through the portal we have to load, or in future, there'll be incremental updates to this layer, and they get put into the spatial database. And it could be something that could be set up as a routine if more and more data is going in more frequently. So this is just a slide showing just where the layers are. So if you're looking in the super table, in the Aegis, the spatial database, there's Flora tree condition sites TLM, and TLM being the abbreviation for the Living Murray methodology. And there's a supporting table that has a bit more information on individual trees. And this is, I wasn't brave enough to do a live demo, but this is just a screen grab of a desktop ArcMap document with the sites pulled in for, and this is just focusing in on Pike floodplain. And you can see the different colours relate to the different condition, and that's the condition in 2009, and that's the condition in 2015. And like as you toggle between them, you can kind of see some changes. But the actual benefit of having the data in a GIS means you can maybe start looking at trend or the change in the condition, so if it's getting better or getting worse. But where you've got things getting better, it could be a real bad site that's getting slightly better, and we've got it green. So the real benefit comes when you combine the condition and the trend. So you can see good sites that are staying the same or getting better, bad sites getting worse, or some of the bad sites with an increase in tree condition. And if we kind of take a demo for maybe selecting that particular site out there, it's pretty easy to hyperlink back to the charts that are generally used in the way the data was compiled when it was just done in Excel for tech reports. And if you were to pick on the floodplain and select the floodplain and say, well, we're interested in river red gum trees that are on the site, then you can start looking at the TCI and the percentage of the trees that are greater or equal to 10% tree condition index. And here it's about 47.3%, so well below that 100% target that we had set for that particular floodplain. So there's some work to do, and hopefully environmental watering will improve the condition there. Just looking at the hurdles of using BDBSA, the extra fields that are in BDBSA now that hold the tree condition data weren't there about 5 years ago, so it would have been a hurdle to get this data in more than 5 years ago, but it's not a hurdle now. There's 12 extra fields. I guess the hurdle was trying to come up with a conceptual way of picturing these tree condition assessment sites, which was the transects of 30 trees, and how to get them into BDBSA. So we've kind of come up with each tree is essentially a patch, and they're linked by a common naming convention that's been used. And the revisit over time is essentially the monitoring activities. The benefits, and we've heard a lot of this mentioned before for BDBSA, the standards are there for the tree condition data, and getting the data in, there is an element of QA and QC for the crown extent and density values and percentages as they've been entered. It consolidates projects, so where I was looking at Pike floodplain of that demonstration, there's 21 sites. In the actual layer that gets generated and is in SDE, there's an additional 41 sites that have also used this methodology as well. And as Matt said right at the start, you're collecting once and using many times. Extracting data from the BDBSA for tree condition means you can draw on all this data already collected. It's that repository where you can go as a single point to get it all and reuse it for important things that the department has to report on, like Matter 8. My wish list is kind of a little bit different. It's not down at data in particular. I guess it's about the recognition of the suite of database systems that we have that kind of collectively form the BDBSA.